Types of chemical reactions. Synthesis and decomposition reactions. Here are some key terms we need to make sure we understand. A precipitant is an insoluble solid formed in a chemical reaction. Synthesis reaction is a chemical reaction in which two or more reactants combine to produce a new product. A decomposition reaction is a chemical reaction in which a compound breaks down or decomposes into two or more simpler compounds or elements. So how do we know a chemical change has occurred? Studying chemical reactions involves looking closely at chemical changes. You are already familiar with several chemical changes. When wood in a campfire burns, a chemical change occurs. Photosynthesis, in which plants change water and carbon dioxide into glucose and oxygen, is also a chemical change. New substances are made in each of these processes. It's not always easy to tell if any substance forms during a change. Here are some clues, however, that you can use to tell if a chemical change has occurred. For example, a reaction might create a new product that is an insoluble solid called a precipitant. This precipitant is a new substance, and therefore it is evident that a chemical change has occurred. Classifying chemical reactions. The new substances or products that formed during chemical changes will depend on the type of reaction, chemical reaction, occurring. Understanding the different types of chemical reactions will allow you to identify which products are most likely to form. Chemists classify chemical reactions into different categories. We will cover 4 different types of chemical reactions: synthesis, decomposition, single displacement, and double displacement. The name of each reaction provides a clue about how they react and change into products. As you learn about each of the 4 types of reactions presented in this lesson, be sure to note that reactive, then the products formed. You might want to record what you learned using a graphic organizer. This will help you to recognize the reaction types and to make predictions about their products. Synthesis reactions. Recall that both oxygen and hydrogen exist as diatomic molecules. Some other diatomic molecules you should know are nitrogen, N2, fluorine, F2, bromine, Br2, iodine, I2, and chlorine, Cl2. It is important to keep in mind that these elements exist as diatomic molecules and that all of them except bromine and iodine are gases at room temperature. At room temperature, bromine is a liquid and iodine is a solid. This knowledge is important when indicating reactants and products in a chemical reaction. The Haber process. One important product made by a synthesis reaction is ammonia, NH3, as a gas. Ammonia is an important component in fertilizer. Nitrogen is essential to all living things. To optimize crop yields, farmers often supply nitrogen to their fields by applying fertilizer. Ammonia also serves important roles in making paper and extracting zinc and nickel from ores and explosives, and in cleaning products. Ammonia is the product of the synthesis reaction between the elements nitrogen and hydrogen. Fritz Haber, a German chemist, patented a process for performing this reaction in 1910. Chemists often refer to this reaction as the Haber process. The reaction is carried out under high temperature and pressure. The balanced chemical equation for this reaction is N2 plus 3H2 produces 2NH3. Synthesis of atmospheric pollutants. Many atmospheric pollution problems are associated with synthesis reactions. For example, natural gas in the atmosphere can react with oxygen to form a class of compounds called nitrogen oxides. These compounds are gases composed of different proportions of nitrogen and oxygen. A colorless molecular compound called nitrogen monoxide, NO, is initially formed in a reaction that is represented by the chemical equation N2 plus O2 produces 2NO. The nitrogen monoxide then undergoes another synthesis reaction that produces a brown reactive gas called nitrogen dioxide, NO2. Second, this reaction occurs according to the chemical equation 2NO plus O2 produces 2NO2. Synthesizing binary ionic compounds. Although products of chemical reactions are identified and studied experimentally, it is sometimes useful to determine the products that are most likely formed in reaction for the synthesis of binary ionic compounds composed of metals with one possible ion charge. You can use ion charges to determine the most likely product. I want you to pause the video, read through the sample problem on this slide, and then practice writing the products in the decomposition of ionic compounds by completing these practice problems. All right, continuing on. Welcome back. Decomposition reactions. A decomposition reaction is a chemical reaction in which a compound breaks down into two or more products. Decomposition reactions can be represented by a general chemical equation. AB produces A plus B, or blue-red would break apart into blue and red. The product may be any combination of elements and compounds, but the reaction will always be a compound. A decomposition reaction is the reverse of a synthesis reaction. Let's take a closer look. An essential component in the development of hydrogen as a fuel source is the ability to produce sufficient amounts of hydrogen. One way that hydrogen gas is produced is through the decomposition of water. Electric current is used to break apart the bonds between the hydrogen and oxygen atoms to form separate elements. The reactions represented by the chemical equation H2O produces 2H2 plus O2. This process is referred to as the electrolysis of water. Almost 4% of the hydrogen gas used in the world is produced by the decomposition of water. A diagram of electrolysis is shown. Decomposition reactions and explosives. Electrolysis of water is an example of a decomposition reaction that results in the production of elements. The tremendous forces associated with the explosion in the picture shown are the results of the decomposition reaction that produces several substances: trinitrotoluene, TNT, which is C7H5N3O6, is a commonly used explosive that decomposes into elements and compounds according to the chemical reaction equation. 2C7H5N3O6 produces 3N2 plus 5H2O plus 7CO plus 7C. Three of the products of the decomposition of TNT are nitrogen, water, and carbon monoxide, and these are gases. The formation and rapid expansion of these gases pushes materials away from the blast site, producing the explosion. Just as you saw for the synthesis reaction, it is sometimes useful to identify the products that are most likely to form in the decomposition type of reaction. For the purposes of this course, you will learn to determine the most likely products of decomposition reactions of ionic compounds that form elements. During the decomposition of an ionic compound, electrons transfer back to the atoms of the metal, and each element becomes electrically neutral. Pause this video again and read through the sample problem given, and then practice writing the products in the decomposition of ionic compounds by completing the practice problems. You will submit the practice problems when you are finished. The next time you go out, look around and notice the many things that are made using concrete. A component of concrete is the ionic compound calcium oxide, CaO. Calcium oxide is made by decomposing another ionic compound, calcium carbonate, CaCO3. Calcium carbonate is mined in the form of limestone. When calcium carbonate is heated in a kiln, it decomposes into calcium oxide and carbon dioxide. The balanced chemical equation for the decomposition of calcium carbonate is CaCO3 to produce CaO plus CO2. When needed to make mortar or plaster, it is combined with water in the synthesis reaction CaO to produce H2O plus COH, 2, aqueous. The resulting mortar is watertight and has enough flexibility to prevent cracks.